When we talk about spherical surfaces in optics, there are certain measurements that we have to be familiar with. First of all, we of course have to keep in mind that our circular drawings are actually two-dimensional cross-sections that we're using to represent a three-dimensional sphere. And every sphere will have a center of curvature, which we'll label C, and then the distance from the surface of the sphere to the center we would label R for the radius. Now if we were to choose any 2 points along the surface of the sphere and draw a straight line between them, that straight line would be called the chord. And the chord can vary in size depending on where those 2 points are. These are 3 different chords that are all on the same spherical surface. The measurement that we are usually concerned with is actually half of the chord length, and we label that as Y. So the entire chord has a length of 2Y. If we were to draw a perpendicular line from the middle of the chord to the surface of the sphere, we would call that the sagittal height, or sag. And you can see that as our chord is increasing in size, the sag is also increasing in size. And as the chord is closer and closer to the center of curvature, the sag is getting larger and larger. And you can see how the relationship between the chord length and the sag gives us information about the curvature of the spherical surface. We could consider another chord of the same approximate length, but if this were a chord, a smaller sphere, a smaller spherical surface, that means that this spherical surface is more curved. The sagittal height, the sag, will actually be larger for this surface. So the way that we relate the chord length, the sagittal height, the sag, and the radius of curvature is usually with an approximate formula, which is that the radius of curvature is equal to squared half the chord length divided by 2 times the sagittal height. This approximation works really well if your sag is much less than the radius of curvature, so maybe a situation like this one. However, as the chord is moving closer to the center of curvature, you can see that the sag is coming closer and closer to the radius of curvature, and we would need to use a more exact formula, which is that R is equal to y squared over 2s plus s over 2. So for most of our problems and most conditions that we'll deal with, especially with spectacle lenses, we can use the approximation, but there are some situations, such as when we're talking about optics of contact lenses, where you have to use the exact formula. So we will discuss a little bit more about how we can use these measurements when we talk about lens clock readings.